this is the old ambient, Malaysian ambient air quality standard. Remember just now we got about 43 micrograms per meter cube. So we use that and compare it. We compare that value with the standard to check whether it is above or below the standard. If it's above, that means it's exceeded the limit. If it's below, it is within the limit and it complies to the standard. And this is the old one. These are the more. Actually, the ones that are the 5 criteria pollutants. Right now, the 6 criteria pollutants are ozone, carbon monoxide, nitrogen dioxide, sulfur dioxide, particulate matter. Last time it was just PM10. Now we have PM2.52, and I think they removed the total suspended particulate from the standard now. This is the old one. So let's look at the new one straight away without wasting time. So again, we see the criteria pollutants: PM10, PM2.5, sulfur dioxide, nitrogen dioxide, ground level ozone, and carbon monoxide. These are the values for particulate. PM10, it's 50 for the 1 year average. 1 year average means that it's averaged throughout the year. Like say you have PM10 values for every hour of the year. Once you average all of them up, you get a smaller value, and that average value cannot exceed 50 micrograms per meter cube. The 24-hour average is the concentration of PM10 for every hour for 24 hours averaged, and that is higher, 150. You understand why it's higher, right? Because you average it over 24. If 365 times 24 is a bigger number, that reduces the average, this value here. Let's just focus on this one first. For PM2.5 is 35 for 1 year average, 75 for 24-hour average. Sulfur dioxide is higher, 350, 1 hour average, 24-hour average is 105. Notice that there's no 1 year average for sulfur dioxide. Okay, nitrogen dioxide is 1 hour, 24 hours, you see the value. Ground level ozone, 1 hour, 8 hours. Okay, carbon monoxide, 1 hour, 8 hours, and so on. Look at the values. But this is for 2015, because there is a requirement that we need to improve the standards. That means we need to make it more strict with years. So at the 2015, it was this value, this range. In 2018, which is now, we follow this range now. Notice it's lower, 50, 45, 150, 120, and so on. And by 2020, it will be this value. Now, this value is based off of the World Health Organization standard. Am I correct, Dr. Hani? Yeah. So, you look at, of course, you see, because we are a developing nation, and anytime you just say, why don't we just straight away use the strictest, right? But because we are a developing nation or a country, we depend on the industry, and industry, if there is a lot of industry, then there's tend to be higher concentration of air pollution. So we cannot set strict requirements at the beginning. We have to give them some time to adjust or to add more better technology so that they can reduce. So that's why they do it in a staggered manner. But the goal is to go down to the WHO standard, which is quite strict. And then at PM2.5, for example, it's at 15 and 35. This is pretty low. Even now, I think the standard, if you go out, I mean, we think it's clear sky. The clear sky value is about this. So there's no smog at all in the air. And that's not what we observe most of the time, right? You see some haze, some smog, some dust in the air. So regulations state emission as concentration. Notice the standard is in concentration, micrograms per meter cube. It's not rate. What we need in air quality modeling is the emission rate. So need to change from emission concentration from normal meter cube to meter cube using ideal gas law. Okay, this one is actually not related to this one. Oh, actually this is from the old standard, because in the old standard there is this unit called NM3. N stands for normal meter cube. It's at a standard temperature pressure of 0 degrees Celsius and 1 atm. You'll sometimes see this, and then you need to convert from this to meter cube using this ideal gas law, but we don't go into that for now. So the important point here is that this we cannot use that concentration from the standard. We need to use the rate. So if you want to use the rate, we need to have some form of velocity. So we need to get this volumetric flow rate of the chimney in meter cube per second, or the ACFM, the actual cubic feet per minute, feet cube per minute, so that we can convert the concentration to rate. Then once you get your results like just now, 47, 43, we compare that result, the modeling result, with the MAAQS. The best stringent guideline to follow is World Health Organization, which is the last one at 2020. And the air pollutants, first, casual, others, you need to model to distinguish between the different pollutants is the emission rate of the pollutant. So we get this result from the modeling, then we compare with MAQS to see whether it's above or below, and then we do it for the other pollutants, iteratively. So this is the WHO guideline. From studies, they say that these concentrations would not have a bad effect on human health, and that's why they set it at these values. But you notice that they're quite low, at 25 and 50. It's very, very low. I think there's never a day in Penang, at least, that's lower than 25. It's definitely about 50, 40, 60, but we don't notice it. We just see it's actually quite clear, but then never have we reached. I think maybe sometimes, but not all the time. Maybe after a very heavy rain episode, then we'll get it. But right away after that, it'll go back up to 50, 60. We only start to see the effects of pollution once it reaches about 100. Then we see some haze in the air. That is from my observation.